Hello everyone. In this lecture, we are going to study the topic partial correlation coefficient. Partial correlation coefficient. The meaning of partial correlation is the correlation between two variables remaining after removing the linear effect of third variable is called partial correlation. So here we are considering three variables x1, x2 and x3. So partial correlation between x1 and x2. Partial correlation between x1 and x2 with respect to x3 is denoted by R12.3, and which is the correlation between x1.3 and x2.3. So what is x1.3? By definition, x1.3 as the formula x1 minus b13 x3, and the formula for x2.3 is x2 minus b23 x3. So here the by definition correlation has the formula covariance between x1.3 comma x2.3 divided by under root of variance of x1.3 and variance of x2.3. So here first we find the covariance between x1.3 and x2.3. We know b13 has the formula sigma 1 upon sigma 3 r13, and b23 has the formula sigma 2 upon sigma 3 r23. Correct? So here by putting these values we get the covariance between x1.3 and x2.3 has the formula summation over x1.3 x2.3 upon n, and the minus mean terms are 0. We know x1.3 and x2.3 bar is 0. So here we replace the terms first by x1.3. What is the formula? Summation over x1 minus b13 x3, and second term is x2 minus b23 x3. So we divided by whole divided by n, which is equal to, so here this we take a product of brackets, so 1 upon n, I take a summation in a product and summation also inside, summation over x1 x2 minus second term is we multiply this term by this, so b23 upon n is constant, take outside the summation, so this term multiply by this, so you get summation over x1 x3, then x2 multiply this term multiply by second bracket, so minus b13 upon n is constant, then summation over x2 x3, last by multiplying this minus minus will be plus b13 b23 summation over x3 square upon n. Then this term is summation over x1 x2 upon n is the correlation has the formula b1 covariance, correct? Covariance between x1 and x2 has the formula summation over x1 x2 upon n, and to get the covariance correlation means R12 has the formula covariance of x1 x2 upon sigma 1 sigma 2. So finally we get covariance of summation over x1 x2 means this summation over x1 x2. So covariance of x1 x2 R12 has the formula summation over x1 x2 upon n sigma 1 sigma 2. So we can replace this term by uh, summation over x1 x2 upon n is sigma 1 sigma 2 R12 minus summation over x1 x3 upon n. Also we can replace summation over x1 x3, you know, summation over x1 x3 upon n, that also we replace by R13 sigma 1 sigma 3, and the this B23 as it is sigma 1 sigma 3 R13, correct, minus uh, this B13 as it is B13 then summation this term we replace by sigma 2 sigma 3 R23 plus B13 as it is B23 also there, and this sigma 3 square sigma 3 square. But we know B23 as the formula sigma 2 upon sigma 3 R23, correct, and B13 has the formula sigma 1 upon sigma 3 R23. So we replace that terms and we get first term as sigma 1 sigma 2 R12, correct, minus B23 we replace by this term, so we will get sigma 2 upon sigma 3 R23 sigma 1 sigma 3 R12 minus, so this term B13 we replace by sigma 1 upon sigma 3 R23 sigma 2 sigma 3 R23 plus B13 we replace by sigma 1 upon sigma 3 R13. B23 we replace by sigma 2 upon sigma 3 R23 and sigma 3 square. So finally we get sigma 1 upon sigma 2 R12 minus, here sigma 3 gets cancelled, what is sigma 1 sigma 2 R12 R23 minus this sigma 3 gets cancelled, sigma 1 sigma 2 R, here is summation over B13, so R13 R13 R23 plus this sigma 3 and sigma 3 square gets cancelled, sigma 1 sigma 2 R13 R23. So these two terms are same, so this gets cancelled. What is remaining? If we take a common sigma 1 sigma 2 R12 minus R12 R23, but you know this is the formula for if we take a minus sign common, minus sigma 1 sigma 2 in bracket r1 to r2 3 minus r1, correct? So which is equal to minus sigma 1 sigma 2, and this is your capital R1 2, correct? Partial correlation coefficient R1 to R1 3 and R1 2, correct. Similarly, we find the variance of x1 dot 3. To get the variance of x1 dot 3, first we put the formula variance of x1 dot 3 means directly we take a, because the min term is 0, so we can write the formula directly, summation over x1 dot 3 square upon n. What is the formula for x1 dot 3? Already we calculated here x1 dot 3 by putting the terms. X1 dot 3 is x1 minus b13 x3, x1 minus b13 x3. So summation over x1 minus b13 x3 bracket square divided by n. So first we square the term and take a summation inside. So first we will get summation over x1 square upon n, correct, minus 2 times b13 summation over x1 x3 upon n, plus last term is b13 square summation over x3 square upon n. So by squaring the terms, then by taking summation inside and replacing the terms, we will get, this is your variance, correct, that is sigma 1 square minus 2 times b13 is what, sigma 1 upon sigma 3 r13, and what about this summation over x1 x3 upon n? So that term we replace by, here we calculated r sigma 1 sigma 2 r12 for this. So here sigma 1 sigma 3 r13, correct, plus b13 is sigma 1 square upon sigma 3 square r13. What is this summation over x3 square upon n? That is sigma 3 square. So which is equal to sigma 1 square as it is. So this sigma 3 and this sigma 3 gets cancelled. What is remaining? Minus 2 times sigma 1 square, correct, then r13 square plus sigma 3 square sigma 3 sigma 1 square r here is r13 square, so here is also r13 square, which is equal to sigma 1 square. So this one term gets cancelled, two same terms are there, minus sigma 1 square r13 square, so which is equal to, if you get sigma 1 square common, 1 minus r13 square. But you know this is the formula of 1 minus r13 square means capital R22, sigma 1 square into R22, correct. So by putting the values similarly, this is variance of x1 dot 3. Similarly, we can find variance of x2 dot 3. That formula is sigma 2 square. This is for R1 dot 3, so capital R1, correct? Sigma 2 square capital R11. So by putting all the values, already we calculated first term, that is covariance between x1 dot 3 and x2 dot 3. The formula for that is minus sigma 1 sigma 2 R12 divided by under root of variance of x1 and variance of x1 dot 3 and variance of x2 dot 3. So variance of x1 dot 3 already we calculated here. That final answer is variance sigma 1 square r11, correct, under root of this term, and this is sigma 2 square r, sorry, here is r22 and here is capital R11, so which is equal to, so this sigma 1 square sigma 2 square, this gets cancelled, so final answer is minus r12 upon under root of r capital R11 r22. So this is the partial correlation coefficient. R12 dot 3 has the formula minus capital R12 divided by under root of capital R11 r22. Similarly, the partial correlation coefficient between x1 and x3 by removing the effect of x2, so linear effect of x2, so you get by this minus r13 upon under root of capital R11 r33. Similarly, the partial correlation coefficient x2 and x3 with respect to x1 r12 dot r23 dot 1 has the formula minus capital R23 upon under root of R22 R33. So in this way we get the expression for partial correlation coefficient between x1 and x2 by with respect to x3, x1 and x3 with respect to x2, and x2 and x3 with respect to x1. So in this way we find the expression for partial correlation coefficient. Thank you for watching.